Good morning, children. In today's class, we are going to learn derivative as rate of change. Where and all you have come across this word rate? See, in physics, what is velocity? It is rate of change of displacement. And what is acceleration? It is rate of change of velocity. So like this, in very many problems, as we want to define, we use this word rate of change. Whenever this rate of change is coming, I can remember it is d by dt provided time is mentioned in that problem. See, when we are reading some speedometer, it may say 70 kilometers per hour. So kilometers per hour. So how much distance in 1 hour it is covered. So that we have rate of change. So rate of change, whenever we come across in normal life situations, we can treat it as d by dt of displacement. So I will put ds by dt for velocity. Rate of change of velocity tells me dv by dt. That is for acceleration. Instead of v, I can put ds by dt. Instead of v, I am putting ds by dt. So it becomes double derivative or second derivative. D square s by dt square. So in problems coming across with velocity and acceleration, let us remember ds by dt gives us velocity, dv by dt or d square s by dt square gives us what is acceleration. The next idea, when a particle is moving upward, I will say velocity is positive. When a particle is moving downward, we will say velocity is negative. So what happens? Upward to downward or forward to backward, it changes the symbol. Here it is positive, whereas here it is negative. In that case, at a particular point here, where it is changing the direction, it is called the particle changes in direction, and most of the cases we put velocity 0 because plus symbol to minus symbol it is changing. But in certain problems finding that V0 may be difficult. But in most of the problems we can use this idea particle changes direction. We will say velocity changes in direction, or in simple words, in simple problems, we can use velocity 0 for particle changing the direction. The next idea, particle is at rest. What does it mean? Forward or upward, I said positive. Backward or downward, I can say negative. So particle is at rest tells me velocity is 0. So these are the formula that we often come across. Now yet another question. When the particle changes direction like this, here, here and all, find the time limit, say t1, t2 like that. Now I want the distance covered. It cannot be simply adding it all. When the particle changes direction, at T1 it is changing, at T2 it is changing. So subtract. This we call distance traveled from T1 to T2. So there are so much of like partitions we have. We add it all. T2 minus T3. So from 2 we need to start with. Suppose my question is from 2 seconds to 5 seconds. And it is changing direction at 3 seconds and 4 seconds. How will I write it? S of 2 minus S of 3, because that is one distance, one direction. S of 3 to S of 4. So we will say S of 3 minus S of 4. And finally S of 4 minus S of 5. So I want it from 2 to 5, in which I have 3 and 4 partitions. So 2 to 3, 3 to 4 and then 4 to 5. In this way, we find out the distance covered from 2 seconds to 5 seconds. The next important idea, rate of change, we have two sections. Average rate of change, instantaneous rate of change. What is the difference? Average rate of change I can find in an interval. Instantaneous rate of change I can find at a point. Remember, so whenever they give you interval and they want the average rate of change, let me say the function is f of x. How to find it? F of the ending minus f of the beginning divided by b minus a. So what is the formula? When the interval is from a to b, I will say f of b minus f of a by b minus a. Instantaneous rate of change, a very simple idea. Just find the derivative at the point x. F dash of x we say, or I can say df by dx, something like dy by dx. So just find the derivative and substitute that point x value. So instantaneous rate of change will be just the derivative, say f dash of x. Having learned these little formula, let us proceed with the exercise problems. Exercise 7.1, question number 1. A point moves along a line in such a way that the distance after t seconds from the origin is s is equal to 2t square plus 3t meters. Find average velocity between t equals to 3 and t equals to 6 seconds. Also, instantaneous velocities at t equals 3 and t equals 6. Given s, let us write it. This represents distance. My question is average velocity. So they have given two time limits. Find out distance at 6 seconds minus distance at 3 seconds divided by the difference 6 minus 3. So this is the formula for average velocity. What is s of 6? Wherever t comes, substitute 6. 2 into 6 square plus 3 into 6. Or I get 19. S of 3. 2 into 3 square plus 3 into 3. 18 plus 9, that is 27. Putting it back in average velocity. 90 minus 27 divided by 3. That is 63 by 3, which is 21. How to write the units? It is meters per second. Distance here, time here. So distance in meters, time in seconds. So my unit will be meters per second. The second question is instantaneous velocity. What is instantaneous velocity? Just differentiate with respect to the time. So ds by dt tells me 2 into all the formula that I know for x, I will apply for t. Remember, x square becomes 2x. Here t square is coming. So t square will become 2t. Same way, x will become 1. In this section we have t. T will become 1. So my answer is 4t plus 3. Now I want at 3. So at t is equal to 3, velocity is equal to, wherever t is coming, substitute 3. 4 into 3 plus 3, that is 15. At t is equal to 6, substitute t equal to 6, v equals 4 into 6 plus 3, that is 27. So every time remember to write the units, it is meters per second. Here also meter in the numerator, time in the denominator. Tells me the unit is meters per second. Question number 2. A camera is accidentally knocked off an edge of a cliff. which is 400 feet high. The camera falls a distance of s is equal to minus 16t square in t seconds. How long does it fall before it hits the ground? Second question, average velocity during the last 2 seconds. Third, instantaneous velocity when it hits the ground. So how are we to do the problem? First thing, look at this picture. The camera is here. Maybe this height we have taken 400 feet, and when the camera is knocked down, it is falling down. And what is the equation given? X is equal to minus 16t square. If it is falling down, this height will be in negative. So minus 400. S is equal to minus 400 when it hits the ground. So hits back means it is S is equal to minus 400. Substitute here, minus 400 equals minus 16t square, or t square is 400 by 16, that is 25. T equal to square root of 25. Do not take negative symbol, time in positive, so time is 5 seconds. First part of the question is over. When the camera is falling down, the distance 400 is becoming negative because it is falling downward. Put S is minus 400 and we arrive at t value. Second question, average velocity during the last 2 seconds. So 5 seconds it is on the ground. In 5 seconds it is on the ground. Then what do you mean by the last 2 seconds? So this will be somewhere here. Let me say it is 3 seconds. So last 2 seconds tell me 3 to 5 seconds. So we have to find out average velocity between t is equal to 3 and t is equal to 5. How to find it? What is average velocity formula? It is s of 5 minus s of 3 divided by 5 minus 3. Find out s of 5. What is s of 5? Wherever t is coming, I have to put 5. Minus 16, 5 square, or minus 16 into 25, that is 400. What symbol we get? Minus. Then s of 3. Minus 16 into 3 square equals minus 16 into 9, that is minus 144. Substituting back in average velocity, we get average velocity equals s of 5 value minus 400 and s of 3 is minus 144, which is plus 144 divided by 5 minus 3 is 2, or I get minus 256 by 2, or it is minus 128. Velocity tells me it is, here what is the unit given? Check it, feet. So what will I write? Feet per time in seconds. So average velocity is minus 128 feet per second. This negative symbol tells me it is falling downward. Upward motion, it is a positive symbol, and downward motion, it is a negative symbol. The third question, I need to find instantaneous velocity. What is instantaneous velocity? Meaning it is ds by dt. That is s is equal to minus 16t square. Minus 16 as it is, t square when I differentiate it is 2t. Remember, x square will become 2x. In the same way, t square will become 2t. That is minus 32t. That is minus 32 into, my question is instantaneous velocity when it hits the ground. Hitting the ground at 5 seconds. So put t is equal to 5 and whatever answer we get, let us subtract it. So this again the units are feet per second. So here we will say hits the ground implies time is 5 seconds. So put t is equal to 5 and get the answer. We'll see the outline once again. Given s is equal to minus 16t square, when it falls down, it is 400 down. So minus 400 for s, giving t is equal to 5 seconds. Average velocity is between the last 2 seconds, tell me 5 seconds it is reaching. So last 2 seconds is 3 seconds to 5 seconds. S of 5 minus S of 3 by 5 minus 3 giving minus 128. Instantaneous velocity, the formula is ds by dt. When I differentiate, S becomes ds by dt minus 16 as it is. T square will become 2t. Multiply and substitute t is 5 because the question is instantaneous velocity when it hits the ground. So hits the ground tells me t is equal to 5. Substituting we get minus 160 feet per second. Question number 3. S of t equals 2t cube minus 9t square plus 12t minus 4 where time is greater than or equal to 0. This is the distance traveled by a particle. At what time the particle changes direction? Total distance traveled in first 4 seconds. Particle's acceleration each time the velocity is 0. In this problem, as I read out, I come across distance that is already given here as an equation, velocity as well as acceleration. So my very first step is find out what is velocity and acceleration. What is velocity formula? It is V, I can say ds by dt. First time I differentiate, I get velocity. Acceleration, let us mark A, it is second derivative d square s by dt square. So first time I differentiate distance, rate of change of displacement we call velocity. Whenever you come across rate of change of in the definition, differentiate with respect to t. The word rate tells me differentiate with respect to time. This is equal to 2 as it is, t cube is 3t square minus 9 as it is, t square is 2t plus 12 as it is, t will become 1, 4 is a constant will become 0. Simplifying this, 6t square minus 18t plus 12. When I say acceleration, this derivative once again I have to differentiate because first derivative gives me velocity, second derivative gives me acceleration. 6 as it is, t square will become 2t minus 18 as it is, t will become 1, 12 is a constant will become 0. So we get 6 is common in both. So I get 2t minus 3. 6 I have taken, it is 2t minus 3. This is acceleration which we will use in the latter steps. Now coming back to the question, at what time the particle changes direction? See, a particle is going like this way. When it is changing the direction, suddenly it cannot change. At this point, velocity should become 0. Again, if it is changing the direction, at this point, velocity should become 0. So this question tells me at what time particle changes direction. Put velocity 0 to get the time when the particle changes direction. So what is the velocity that we have found out? Let us put it equal to 0. Particle changes direction when v equals to 0. That is 6t square. As I put it equal to 0, we get 6 is common. So t square minus 3t plus 2 equal to 0. Factorizing 2 and I need minus 3. 2 ones are, because this is negative, minus minus. Check it. Minus into minus plus. 2 ones are 2. Minus 2 minus 1 gives me minus 3. Putting it back here. T minus 2 into t minus 1 equals to 0, or t is equal to 1 comma 2. So particle changes direction at 1 second and 2 seconds. Second question, total distance travelled in first 4 seconds. See, we know the particle changes direction at 1 second and 2 seconds. So, first 4 seconds I need to split it. How do I split it? 0 to 1, 1 to 2, 2 to 4, because it changes direction. Somewhat like this it may be. So, 0, 1, 0 to 1, 1 to 2, 2 to 4. As it is changing, we must substitute in the formula like that way. So, S of, how will I write it? S of 0 minus S of 1, first distance, plus S of 1 minus S of 2, second distance, S of 2 minus S of 4. Why we didn't put 3 in between? Changes direction only at 1 and 2. So 0 to 1, 1 to 2, 2 to directly the seconds. So I have to find out like this. Instead of S of 0 minus S of 1, you can very well put S of 1 minus S of 0. So put modulus and find the distances. As we try to find out what is S of 0, in S equation, let us put, wherever t comes, let us put 0. So 0, 0, 0, minus 4. So my answer is minus 4. When I say S of 1, 1 cube is 1. 1 into 2, 2. Minus 9 plus 12 minus 4. So when we put 1, simply the numbers will come. 2 minus 9 plus 12 minus 4. Simplifying which we get 1. When I put 2, 2 cube is 8. 8 into 2, 16. 2 square is 4. 4 into 9, 36. 12 into 2, 24 minus 4. Simplifying we get 0. Then when I put 4, 4 cube is 64 into 2, 128. 4 square, 16 into 9, 144. 12 into 4, 48 minus 4. And we have simplified, which gives us 28. As we know all these values from here, let me substitute. What is S of 0? Minus 4 minus S of 1 is 1 plus S of 1 is 1, S of 2 is 0. S of 2 is 0, S of 4 is 28. Simplifying 5, 1, 28. Even if negative symbol comes, modulus gives out positive. So the total answer is 34, and 34 will be the distance travelled in first 4 seconds. No units are mentioned in the question anyway. Since it is distance, let us put that many meters. Third part of the question. Particle's acceleration each time the velocity is 0. Velocity is 0 gives me time 1 and 2 seconds. Put 1 and 2 in acceleration formula. So when t is 1, acceleration is 6 into t value 1, 2 into 1, 2 minus 3. That is minus 1 into 6, which is minus 6. When t is 2, 6 into 2 2's are 4 minus 3. So I get plus 6. And what are the units for acceleration? It is meters per second square. So we say when velocity is 0, time is 1 and 2. Put t is 1 and 2 in acceleration equation and get the two values. So first a value minus 6 and second a value is plus 6. Question number 4. If the volume of the cube of length x is v equals to x cube, find the rate of change of volume with respect to x when x is equal to 5 units. V equal to x cube is the equation given where V is the volume and x is the length of it. Rate of change of volume with respect to x. Since they have given V with respect to x, the formula is dV by dx. What is V? X cube. If I differentiate with respect to x, x cube will become 3x square. Given x is equal to 5. So we will say dV by dx equal to 3 into 5 square or 3 into 25 or that is 75. Question number 5. Given mass in kilogram of the length in meters as a function m of x equals to root of 3x. Find rate of change of mass with respect to x when x is equal to 3 and x is equal to 27 meters. Here again we are given m equals to root of 3x, which I can write root 3 into root x. The question is rate of change of mass with respect to x. So rate of change of mass with respect to x will be d mass is m by d x in length, so x, dm by dx. That is dm by dx is equal to root 3 is the coefficient, keep it as it is. What is root x derivative? Root x will become 1 by 2 root x. Let us remember the formula. Root x will become 1 by 2 root x. Given x is equal to 3. dm by dx is equal to root 3 1 by 2. Wherever x is coming, put 3. Root 3 cancels. My answer is 1 by 2. The next idea, wherever x is coming, let us substitute 27. So dm by dx is equal to root 3 into 1 by 2 root of 27. In the place of x, we are putting 27. What is root of 27? 27 can be written as 9 into 3. 9 square root is 3. 3 square root is root 3. So 27 written as 9 and 3. For 9 it is 3. For 3 we don't know, right? Root 3. So root 3 cancels and my answer is 1 by 6. So dm by dx equals to 1 by 2 when it is 3 and 1 by 6 when it is 27. Remember to put the units, mass in kilogram and length in meters. So what is your unit actually? Kilogram per meters. Same way here also, kilogram per meters.